In this section, we're going to discuss properties of water, beginning with a discussion of Earth's early oceans and some hypotheses on where our water originated from. As Earth's crust cooled and solidified, water vapor condensed. It rained for 100 million years, and the oceans formed. For many years, most scientists believed that water was brought to Earth by meteorites in the early solar system. That can't explain, though, the large amounts of water in our oceans. There must be an additional source. While that's still a good hypothesis, other hypotheses have been proposed more recently. Lunar samples taken during the Apollo missions of the 1960s and 1970s show that the water found on lunar soil particles match water particles on Earth. This tells us that the Moon and Earth probably got water from the same source and not just from meteorites. This discovery suggests additional hypotheses about where Earth got its water. So what is the source of our water? Could water vapor have been carried from the sun to Earth and its moon by solar wind? Could it have been carried to Earth as the planets formed from other planets, such as Jupiter or Saturn, where their early orbits crossed Earth's path? There are several hypotheses that could explain where our water originated. Our water probably has more than one original source. The blue planet. 3/4 of Earth's surface is submerged in water. Water is fundamental to life on Earth. Why is this? We'll discuss why in the next slides. But you can see from the image at the right that the immense amount of water covering the surface of the Earth is where it gets its nickname, the blue planet, from. Water molecules. A water molecule consists of 2 hydrogen atoms, as you can see here, covalently bonded to 1 oxygen atom that you see here. The oxygen atom has more protons, so 8 protons in the oxygen atom, 1 in each hydrogen. So the hydrogen electrons are pulled closer to the oxygen atom due to that stronger electric force. So this electron from hydrogen pulled closer to this oxygen nucleus due to that strong positive nucleus. The water molecule still possesses an overall neutral charge, but the oxygen side of the molecule is slightly negatively charged, as you see here, and the hydrogen side is slightly positive charged, as you see here. Water is known as a polar molecule because of the uneven distribution of charge. This is important to the behavior of water and its impact on life. The polarity of water gives it several important properties that allowed life to emerge on Earth. 1, water moderates temperature in its surroundings. 2, water dissolves most substances. And 3, water attracts other water, which is a property known as cohesion. It is cohesive. Let's talk first about how water moderates temperature. Water has a very high specific heat. That means it takes a lot of energy to raise the temperature of water even a few degrees. This means that temperature on Earth's surface is moderated by its water. The temperature doesn't get too hot or too cold. Why is this important to the development of life on Earth? You can either talk about that amongst your group or on your own before you move on to the next property. Water is also known as a universal solvent because of its ability to dissolve most compounds. Life's chemical reactions need to occur in solution. Nutrients can dissolve in water, allowing chemical reactions to occur. The dissolving of compounds in water also lowers its freezing point. The polarity of water molecules cause them to be attracted to each other and to other molecules. The positive hydrogen side of one molecule of water is attracted to the negative oxygen side of another. You can see that in the image to the right, shown by the dashed lines between the water molecules. The bonds are between the molecules, so they're what we call intermolecular bonds, bonds that occur between the molecules. Don't confuse intermolecular bonds with the bonds between atoms that form molecules.
So the covalent bonds are the bonds between this oxygen and hydrogen and this oxygen and this hydrogen. And there are those same covalent bonds in each water molecule. Covalent bonds are a strong bond between atoms, and they form molecules from separate individual atoms. So this is a water molecule formed by 2 atoms of hydrogen and 1 atom of oxygen, covalently bonded. Intermolecular bonds are much weaker. So these dashed hydrogen bonds that you see between the water molecules, they are much weaker. They don't form molecules, they connect molecules together. They do play an important role in the characteristics of matter, including water.
The type of intermolecular bonds formed in this case, hydrogen bonds, are so named as they occur because the hydrogen atom's electron is attracted more by a stronger atom, in this case the oxygen, polarizing the molecule. 2 of the types of attraction that result from hydrogen bonds include cohesion, which is the attraction between water molecules to one another, and adhesion, the attraction between water molecules and non-water molecules. Cohesive behavior. Among other things, this property allows plants to pull water up through their roots, small insects to walk on water, as you see in the image, ice to float. Water bends carbon organic molecules in specific 3D shapes. Cohesion is a factor also contributing to the high specific heat of water, as we discussed in our first property, where water moderates temperature.